Hi,
Hello, Amit. How are you?
I'm fine, thank you. How are you?
I am also fine. Okay. In the
Yeah,
previous in the previous session, I have discussed about system, surrounding, and boundary. Okay,
yeah,
and you remember the fact that system is nothing but system is a region in space upon which we concentrate our study. Okay, to basically study the working substance present in this. Okay,
okay.
so now in today's session we will discuss about the types of system. This is very important for you. Types of system, there are basically three types of any system. First
Yeah,
is your closed system, second is open system, and third one is isolated system. there
yeah,
are there are only three types of system. Okay, so let's start the types of system one by one. Okay, so at first we will discuss about closed system. Okay, so let's move to the closed system. Here, closed system. What is closed system? Then please understand. Let us assume, let us assume a system that is shown here, system. Okay, and everything external to this system, that is surrounding. That is surrounding. When you see that there is no mass transfer between the system and surrounding, but there is energy transfer between the system and surrounding, then that system is called closed system.
right.
Here, as you see, energy in and energy out. Energy is in, energy enters the system from the surrounding, and energy out from the system to the surrounding. That means here there is energy interaction between the system and surrounding.
Yeah,
But here no mass transfer between the system and surrounding. Okay, so this type of system is called your closed system. Okay, I will discuss few examples here so you can easily understand that. Now, now let us assume this is your system. This is your system, and this is your surrounding. This is your surrounding. If there is no mass transfer, if there is no mass transfer from the system to the surrounding, and also there is no mass transfer from the surrounding to the system, that means mass transfer is zero. Mass transfer is zero. But
okay.
but there can be energy transfer from the system to the surrounding, or from the surrounding to the system. That means there will be energy transfer. Energy transfer. So here energy transfer cannot equal to zero. Cannot equal to zero. So this type of system is called closed system. If this happens, if this happens in any system, then you can call that system closed system. Okay, my dear.
Yeah,
Now let's take an example. Let's take an example of this. Now suppose, my dear, in your room, a cup of tea, a cup of tea is placed on the table. Okay, and suppose you placed a plate over the cup. You placed a
okay.
plate over the cup. This is any plate. this is any plate or something else. Okay. So here, what will occur? What happens here? Now, my dear, when you do in this your room, in your home, then you find that tea gets cold. Tea gets cold after some time. Why? Why this tea gets cold? Uh, we put a plate on this cup, but here tea gets cold after some time. That means there is energy transfer, heat transfer from the tea to the surrounding. That means room. This is surrounding, or you can
Yeah.
call room, and this tea is your system. When you put a cup of tea in your room and over it a plate is placed, then you can find that tea becomes cold after some time. Why? Because there will be heat transfer, there will be energy interaction between the system and surrounding through the wall of the cup, through the wall of the cup. Okay. So there will be energy transfer, heat transfer will occur, and heat transfer will be a form of energy interaction. Will be a form of energy interaction. But here, my dear, here energy interaction occurs, but mass transfer does not occur here because we placed a plate over the cup. So mass transfer does not take place here. Here from the system, mass does not go to the surrounding. Mass does not go to the surrounding. Okay. And also from the surrounding, mass does not enter to the system. And also from the surrounding, that means from the room, mass does not enter to the system. That means there is no mass transfer between the system and surrounding here. But there will be energy transfer between the system and surrounding because tea gets cold after some times. That means there is an energy interaction. So this type of your system is called closed system. Closed system. I hope you understand this concept. You understood this concept?
Yeah. Yeah.
This is the example of closed system. Now let's see the definition of closed system. When there is no mass transfer between the system and surroundings, but there is energy transfer between the system and surroundings, then that type of system is called closed system. Okay. Now let's move to the next example. Consider a rigid container. In the previous session, I have taken example of rigid container. This is your rigid container. Rigid container. And let us assume in this rigid container, a liquid is present. Okay. Now, for a rigid container, volume is constant. Okay, because boundary is fixed here. So this is your system. I have to find what type of system is this. So this is your surrounding. Now, my dear friend, here from the system to surrounding, there will be energy transfer. There may be energy transfer between the system and surrounding. If this liquid is at higher temperature than surrounding temperature, then heat transfer goes from system to surrounding. But if surrounding temperature is higher than system temperature, then heat transfer goes from the surrounding to the system. Okay, that means there will be energy interaction. There will be energy interaction. But here, my dear, as you see that the boundary is fixed and this rigid container is closed. This is not open, this is closed.
Closed system. Yeah.
So no mass transfer occurs here between the system and surrounding. No mass goes out from the system to surrounding, and no mass enters the system from the surrounding to the system. That means there is no mass transfer. So mass transfer is 0 here. Okay, but energy interaction is not equal to 0. Energy transfer will not be equal to 0. So this system is called your closed system. Your closed system. Okay, so when you are asked about the example of closed system, please give the example of closed system. Then you please tell them rigid container is a type of closed system. Okay, and the first example, in the first example, a cup of tea. This is a basic example. Okay, but technically, rigid container is your closed system. Okay, technical point of view. Now another example which is very important here, is piston cylinder arrangement. Now let's move to the next example of closed system. This is your piston cylinder arrangement. This is your piston. This is the figure of piston cylinder arrangement with no valves. Here no valves is present. Piston cylinder arrangement with no valves. With no valves. Okay. So this is the figure of piston cylinder arrangement with no valves. So what will happen here? As you see that here no valve is present. And you also know that from the valve, mass enters or out from the system. From the valve. When valve is present in piston cylinder arrangement, then mass can enter the system or leave from the system. But here no valve is present. So no mass enters the system or leaves the system. Okay, because no valve is here. So when a working substance is present here, let us assume this system is at temperature higher than the surrounding. This is your surrounding. Let us assume this system is at higher temperature. That means this liquid has higher temperature. Let us assume surrounding has 25 degrees Celsius temperature and system has 45 degrees Celsius temperature. Then what will happen? Then here energy transfer will occur. Heat transfer will occur from the system to the surrounding. Here energy transfer will occur. Okay, but there is no mass transfer here because there is no valve present. So no mass transfer will occur between the system and the surrounding. Okay, so there will be no mass transfer between the system and surrounding. So mass transfer will be 0. So this is a type of closed system. Okay. This is a type of closed system. So when you are being asked about the example of closed system, then please tell the piston cylinder arrangement with no valves is an example of closed system. Okay, or rigid container. In any device, when you see there is no mass transfer between the system and surrounding, but energy transfer occurs between system and surrounding, then that type of system is called your closed system.
Okay.
Okay, my dear. Okay. Now here one more important point is remaining. What is the point? Please look at this. In every example, my dear, in every example, okay, as you see that mass of the system remains constant because no mass is entering the system or no mass is leaving the system. That means mass remains constant at every time. Every time
Okay.
mass remains constant. Let's look at this piston cylinder arrangement example. Here assume mass is 2 kg. Assume mass is 2 kg. Then think, my dear, does this mass change? No, because mass is not entering, because no new mass is entering or no mass is leaving. So this mass remains constant always. Okay. Now in this figure, rigid container, here also mass of this system, mass of this liquid that is present in the rigid container will also remains constant because no mass is entering and no mass is leaving. So mass remains constant. Okay. So can you call this closed system as control mass system? Because mass is fixed.
Yeah, mass is same. Yeah.
Because
Yeah, you can.
Because mass is fixed here. Mass is
Yeah.
fixed. Mass does not change. So this system is also called control mass system. That means mass is controlled here. Mass does not vary here. Mass remains constant. So this system is also known as control mass system. Okay. So here note point is, our note point is, in the closed system, as no mass enters or leave the system, so closed system is of fixed mass, fixed mass means mass remains constant here. Mass remains constant. Hence this system is also called as control mass system. This is very important, my dear. Control mass system. Okay, please remember, closed system is also called control mass.
Yeah.
Why? Because mass is fixed here. Mass does not get changed. So this system is called control mass system. That means mass here is controlled. Okay. So I hope this concept of closed system You understood all the concept here. Okay, so this was your closed system. Okay, now let's move to the open system. Let's move to the open system. As the name suggests, open system, this means that system is open. System is open. As the name suggests. Previously, you see that closed system. Their name suggests that system is closed. System is closed. So there will be no mass transfer. System, because system is closed. Here, my dear, system is open. Here, the name suggests system is open. And when system is open, my dear, then there will be mass transfer.
Yeah.
Because system is open, then there can be mass transfer between the system and surrounding. Okay.
Yeah.
So please go through the name. 50% of the concept will be clear through the name itself. Okay.
Yeah.
Now let's see the image here. As you see that in the open system, mass will be entered into the system, and mass will leave from the system to the surrounding. This is your system, so this is your surrounding. Here mass transfer occurs between the system and surrounding, and energy also transfers between the system and surrounding. Energy in and energy out. That means here energy transfer also occurs. So whenever you see there is mass transfer and energy transfer, there is both mass transfer and energy transfer between the system and surrounding, then that type of system is called open system. Okay, so here let us assume this is your system. Okay, so this will be your surrounding. When there is mass transfer between the system and surrounding, that means mass transfer occurs. So mass transfer is not zero. That means this is happening there. And also there is energy transfer between the system and surrounding. Energy transfer. This is also not equal to zero. That means energy transfer occurs between the system and surrounding. So that type of system, so this system is called your open system. Okay.
Yep.
Now let's move to the example. In the previous case, in the closed system, I have taken a cup of tea. So see the figure, my dear. In the cup of tea, this is tea. In the previous case, we put a plate over here, over the cup.
Yeah.
But when we does not put a plate over the cup, then what happened? My dear? See, here energy transfer will occur between the system and surrounding, because when you put a cup of tea in your room, you see that after some time the temperature of tea has reduced. That means there will be energy transfer between the system and surrounding, or that means from the tea heat transfer goes to the room. Okay, so there is energy transfer. But my dear, in the previous case, we put a plate over the cup, so there will be no mass transfer. But here, when we do not put a plate over the cup, then what happened? Then, my dear friend, mass will go out. Then mass will go out in the form of vapor. Okay, to the surrounding. Okay, you can check in your house. You can check this phenomenon in your house. When a cup of tea is placed in your room, then please put your hand over the cup of tea. Then you can feel the vapor is coming out from the cup of tea and touching your hand. Okay, that means here mass is coming out from the cup in the form of vapor. So there will be mass transfer, although there will be very less mass transfer in the form of vapor, but there is mass transfer. So this system is called open system.
Okay.
So here mass transfer in form of vapor occurs here. So basically here mass transfer occurs. This is your surrounding. This is your surrounding. So you see that this is your system. So here you see the concept. From the system, mass is transferred to the surrounding and energy also transfers. So this type of system is called open system. Open system. Okay, my dear?
Yeah.
Okay. Let's move to the new example. Let's move to the new example. In the closed system, I have taken an example of piston cylinder arrangement with no valves. But when we take an example of piston cylinder arrangement with valves, when valve is present, then that system is called your open system. How?
Yeah.
Please see the figure. Okay. This is your cylinder. This is your cylinder. This is your piston. Okay. Now here valve is present. Here valve is present. Okay. And in this cylinder, some working substance is present already. Some working substance is present already. Okay. And this is the figure of piston cylinder arrangements. Piston cylinder arrangement with valves. With valves. Okay. Then here what will happen? Since valve is present here, and you know that from valve mass enters the system, and from other valve mass will leave from the system.
Yeah.
That means my dear, here mass transfer will occur. Here mass transfer is occurring. You see that here mass transfer will occur. So mass transfer is not zero here. Here mass transfer occurs due to the valve. Okay.
Yeah.
Now, and here also energy transfer occurs.
Yeah.
Because let us assume this working substance is at higher temperature than the surroundings. Then what will happen? Then from the system to the surrounding, heat transfer occurs. Okay. So this is your system, and outside to the system is called surrounding. So this is your surrounding. So between the system and surrounding, there will be energy transfer. Okay. That depends upon temperature. If the temperature of system is high, then heat will transfer from system to surrounding. And if the temperature of surrounding is high, then heat will transfer from the surrounding to system. Okay. Okay. Now tell me, my dear, here you can see that mass transfer and energy transfer both occur between the system and surrounding. Then this type of system is called open system.
Yeah.
So this system is called open system. So whenever you are being asked about the example of open system, then please tell them the piston cylinder arrangement with valves is an example of open system, because in this example, as you see that mass transfer and energy transfer both will transfer from the system and surroundings. Okay.
Yeah.
Now my dear, in your daily life or in your surrounding, whenever you see a device in which there is mass transfer and also energy transfer between the system and surrounding, then please tell that system is your open system. Okay. Now next example of the open system is turbine.
Yeah.
This is your turbine. Okay. In turbine, you know that mass is entering the turbine.
Yeah.
Mass is entering the turbine and mass is leaving the turbine. Okay. Turbine may be your water turbine or gas turbine or steam turbine. In every type of turbine, mass will enter into the turbine and leaves the turbine. Okay.
Yeah.
So turbine is your system, my dear. Turbine is your system, and you have to classify this system. This system is a closed system or open system or isolated system. Then please look here. This is your system and this is your surrounding. Then what you see here, my dear, what you see here, between the system and surrounding, there is mass transfer. Mass is entering and mass is leaving. That means mass transfer occurs. And also, my dear, here heat transfer occurs.
Yeah.
Okay. Heat transfer means energy transfer. Because I have told you energy transfer will be of two types: heat transfer and work transfer.
Yeah.
So there is heat transfer, that means there is energy transfer. So this turbine is called your open system. Okay. So this turbine is your open system. Every device in which you see mass is entering and mass is leaving are almost your open system. For example, this is your turbine. Now take the example of compressor. In compressor also mass is entering and mass is leaving. You have studied about condenser.
Yeah.
In condenser also mass is entering and mass is leaving, and heat rejection also present there. In the evaporator, okay, in evaporator mass is also entering and mass is also leaving. Every device in which you see the mass is entering and leaving the system, that all devices are almost your open system. So this, let's take another example. This is your compressor. The function of compressor is to compress the working substance. Okay. This is your compressor. In the turbine, the working substance is expanded. Here in turbine, the working substance is expanded, but in compressor, working substance is compressed. Okay.
Yeah.
So in compressor, here mass is also entering, mass in and mass leaves. That means mass out. And also here, there will be energy transfer. There will be energy transfer. So this, this compressor is also your open system. Is also your open system. Okay. This is your system, and this system is called open system. Okay, my dear. So now, I hope these all examples are very clear to you, and I hope you understand the concept of open system. Now, the example of the open system. The example of the open system is, first example, as you have seen that, first example of open system is piston cylinder arrangement. Piston cylinder arrangement with valves. You have to tell with valves. When there is no valve, then that system is closed system. But when valve is present in the piston cylinder arrangement, then that system is open system. Piston cylinder arrangement with valves. Second example is your turbine, compressor.
Yeah.
Condenser, evaporator, boiler, my dear.
Yeah.
You have studied about boiler. In the boiler, water enters
boiler,
and steam leaves out. Okay.
Yeah.
That means mass transfer is occurring there. Okay, between the system and surrounding. So boiler is also example of open system. In every device, my dear, in every device, when you see there is mass transfer, then that system is called your open system. Okay.
Okay.
Boiler, nozzle is also example of open system. Diffuser. Okay. Pump, etc. Okay.
Yeah.
These all are examples of your open system, and I hope you understood this concept here. Now, now my dear, as you have seen in the closed system, I have told you the closed system is also called control mass system. So now the question is, open system is what type of system? Here this is control mass system or control volume system or anything else. So let's see the concept here. Here, my dear, here, as you have seen that in these all types of examples, let us assume this turbine. Then this turbine has this volume, in which for every cycle of operation, the working substance enters and leaves. For every cycle. For every cycle, the working substance is entering in this volume and leaving this volume. Okay. And also in the compressor, this volume is your working volume.